I'm Bob Phalen, and I'm a prof at UC Irvine. By the way, I'll echo Andrew Wheeler as a very smart EP administrator, and I just hope he's smart enough to succeed. I do research, I do teaching, I do public service. The teaching is largely in toxicology and occupational medicine. We have a residency program, and I teach in that. Service, I do to the university, to the government, to the public, and anyone else who needs help. We really have about two main topics here. I'm going to make you familiar with what's called PM. The M could stand for mass, matter, or material, and the P for particulate. We're also going to look at deaths related to PM and try to understand how these claims are made about PM killing people. Then I have a few other comments. Let's look at the monster here. This is an electron micrograph taken at Breathing Zone in California, UC Irvine, several years ago. And you can see the size reference. In comparison, a red blood cell is about 7 micrometers in diameter, and they're very hard to see in a usual optical microscope, a cheap optical microscope. Medical microscopes can resolve them. The interesting particle just above the 5 micrometer size reference is worthy of comment. A German aerosol physicist, Werner Sturber, saw this picture on the wall when he visited my lab. He was poetic. He said, "A bubble burst in the sea, a waft of wind carried the droplet inland. It evaporated, and you captured a particle of sea salt." And that makes sense. The equally successful Ken Whitby, the late Ken Whitby, as an aerosol engineer, saw the picture a few weeks later and said, "That's tire rubber. There's no doubt about it." I have no idea what it is. It's probably sea salt or tire rubber. But the other particles are largely natural. They'll be debris from insects and plants. What you don't see on here, because it wasn't the season, is a lot of pollen, which can definitely cause health effects. The sources are human-made, which are minor, and natural, which are major in this size range. More about PM. It's a national ambient air quality material, and it's a criteria pollutant, so it has to be reviewed every few years, and that gives activists an opportunity to tighten the standards, whether they require that or not. It's the weight of particles, for example, it could be on a filter, below either 10 micrometers in diameter or 2.5 micrometers in diameter. And the 2.5 micrometer cutoff material is called PM2.5. Unlike any other regulated substance, the composition is not considered. Imagine if medications were evaluated for their safety or their efficacy on the basis of how much they weighed, or food additives, or nutrients. But in this case, it's pure mass. Composition is not considered. It's highly variable in time and space, morning to evening, to night. It's very variable in a given location. Different parts of the country have totally different particles, depending how humid or how dry the weather is. It's a mixture, as I mentioned before, of natural and human-generated material, and their products. They interact and make sort of third-level products. When you inhale particles in this size, most of them stick with the air streams and are exhaled. About 25% on the average are deposited in the respiratory tract. And I'd love to go into the physics of that, and I won't. When we discuss PM, generally there's a 3-mode way that you organize the particles. And on this slide, at the bottom is EPA's terminology in terms of ultrafine, fine particles, and coarse particles. These 3 modes are really fiction to some extent, because every source will generate a mode. A particular type of plant, a particular pollen, pine pollen, for example, will generate a mode. So there are really thousands of submodes in these modes. But scientists and also regulators generally think in terms of these three modes. And I'm not going to go into great detail, but the one on the far right is largely natural material. Although some of our processes, grinding and so on, paving, construction, generates coarse particles. Off to the far left are extremely tiny particles. Some of them are not even really visible in an electron microscope, they're so small. Radioactive decay of gases to solid products would be an example. Very high temperature combustion and other sources. Now, this next slide, if you want to ask what are the particle sizes associated with, if you sample a single location with 3 different samplers, you've got one sampler that gives you a picture, as you saw previously, and you look at the count. On the top, you can see where we're plotting the amount, or the count, how many particles there are, versus diameter classification. Most of the particles, by count, are in the 100th micrometer range. That's getting down to where an electron microscope might even have a hard time really giving you a good image. So the person who uses the microscope asks for the particles in the city, what size are they? He'll say, well, they're obviously around 0.01, 0.02 micrometers, because the large particles by count are not there. Biologists who are interested in the way particle surfaces interact with the respiratory tract surfaces might say, well, the surface area is the only thing we're really interested in, because that's what we experience, is the surface. And with surface area monitoring equipment, you see that most of the surface area is in about 0.1, 0.2, 0.3 micrometers in diameter. Now, in terms of mass, basically we can separate particles aerodynamically and then measure the mass after that aerodynamic separation. We see that there are a couple modes. There's the coarse mode off to the right, and then there's the intermediate mode off to the left. When APA was deciding on setting a fine particle standard, there were arguments for PM2.5. I was called in on a telephone conversation, and I argued for 1 micrometer, because that cuts out your coarse material. And the epidemiology, which is the study of clusters of human disease, basically, is contaminated by PM2.5 cutoffs with a lot of natural material. I know an MD Ph.D. that recruited me 43 years ago at UCI was a pulmonologist, and he said a fraction of a pollen grain can trigger an asthma attack in a susceptible subject. And so there'll be fractions of pollen grains in the PM2.5. Now we're going to really shift gears and look at deaths, for example, from PM2.5 episodes. In Los Angeles, we have about 200 deaths a day, and if there is an air pollution episode, that might go up to 200.5 or 201. There's a lot of variability, of course. These episodes occur for 2 reasons. One, the level that is measured is often how much higher is it than a running average of previous days, like say 5 days. So this is really an increment, not a level. It's a change that epidemiologists are usually looking at. The other reason that we would have an air pollution episode of particulate material is we have an inversion. Well, we only have inversions really about 340 days a year in Los Angeles. So considering all of that, when we have an episode, a PM2.5 episode, everything else in the air is going to be concentrated as well. We've got an inversion. One pulmonary physician on a study section I was on, when he saw these data, he said it was the 5 clean days that caused the problem, because we start to lose our defenses within days in clean air. If I wanted to harm everybody here as an aerosol scientist, I would put us all in clean rooms for about a week or 2, and when we came out, we would immediately get sick. we're going to look at John Doe, and he was the 201st person to die that day during the PM2.5 episode. He had a lot of risk factors, and some are listed. I'm not going to go over them in great detail. He's a smoker. Down in the middle is upper respiratory tract infection. During the 1952 London episode, there was an epidemic of respiratory infections coincident with that episode. He had poor mental and physical status, and there was a heat wave, as you can see at the bottom. If you'd like to see a picture, I know a talented artist, and I asked my wife to draw a picture of John Doe. Here he is on this hot day with an inversion. He's smoking, he's drinking a beer, he's sweating. He lost his job. Maybe he worked for Monsanto or something, I don't know. He lost his job. His only friend really is a dog. And it's a hot day. The door is open. And John is going to wind up dead. And so you see him on a gurney there, or a stretcher. The day he died, and remember the dog, the day he died, a truck drove by, the dog chased the truck. John ran outside and ran chasing the dog in the hot weather uphill. He collapsed, and he died in the emergency room of a heart attack. What killed him? Was it the PM2.5? Was it his infection and so on? You can read this list. But I think all of these things combined were required to kill him. Let's assume that a human death is worth about $1 million. And when you see headlines, 64,000 people a year die of PM particle pollution, see 64,000 times a million, that's about $64 billion. So regulatory agencies could say, there's $64 billion worth of damage done, so let's regulate to get rid of the problem. And if it costs billions of dollars, that's okay. It's still a valid trade-off. Also, I mentioned here infection, cigarettes, pollen, and so on are involved. Obesity. So Weight Watchers could claim some of that $64 billion and say, support us. We could have prevented his death cheaper than the regulators. Psychiatrists could say, you know, if we treated his anxiety and stress, we could have prevented his deaths. The next one is very interesting to me because consistently in epidemiology studies, the people that are likely to die are of low socioeconomic status. That includes low educational levels. But in reality, all of the above are involved. To prevent his death, what are you going to do? How about tightening air quality standards? There's a problem there in that I mentioned that in many areas, like for example the West that we're in, it's dry, and PM2.5 is contaminated with natural sources, dust and so on. And if a city is required, for example, to meet the standard, all they can do is things like outlaw, diesel engines and so on. The impacts are very, very severe on activities like farming, transportation, construction, food production especially. I think we had a dairy had to leave our area in California because they couldn't meet the environmental standards. So it's unlikely, really, that you could pin just PM2.5 on John's death. There's something called a metric. A metric is a measure. And a metric has to be defined. In other words, the metric might be acidity in the air, it might be particle mass in the air, and so on. It has to be defined, it has to be measurable. And part of EPA's reason for picking PM2.5 as the metric for fine particulate material was they had their instrumentation all set up for that. They had ways of calibrating it and so on. So they had a lot invested in that, as a measurable quantity. Another thing that a metric has to be is it has to be the cause of what you're worried about, which means if you control that metric, you improve the outcomes. There are many, many positive studies that epidemiologists have associating, and the word association is a really important word. It's very broad, it's very vague. There are all sorts of associations. I think that probably liver disease is associated with limes because people flavor their drinks with lime juice. So association means exactly that. It's not a proof of a cause. There are also many no-effect studies, and in some areas you find PM2.5 is not associated with adverse health effects, including deaths. And it brings up something someone mentioned before, is the exception sort of disproves the rule. If this material is sometimes even positively associated with health, human health, it detracts a little bit from calling it a dangerous pollutant. And I think it's positively associated in some areas because farms produce it, productivity produces it, a good economy produces these particles. I mentioned already that it's the only substance that we regulate that's not chemically defined, and it's not stable over time and place. I mentioned that, and I've mentioned that it's a mixed pollutant, natural, anthropogenic, and then the combination of the two leads to that third level of pollutants. Another factor in whether or not this is a good metric is the doses are very, very tiny. I'm going to do a thought experiment. Einstein did thought experiments. And I'm going to assume that you've got a person who lives in an area that's always at the maximum allowed PM2.5 level. And they always are outside, whereas we're outside about an hour a day. And that this person is breathing the air, and we're going to ask how long does it take for this person to get a gram of material? And the answer is on the order of 100 years. Dr. Enstrom will show you his calculations. He got 80 years, but there's some variation in that. At death, this person who lived their entire 100 years is likely to have about 1/100th of a gram of material in their body because of clearance mechanisms. So the doses are tiny. And Paracelsus, said all things are poisonous and all things are not poisonous. It all depends on the dose. If I were to draw the air in a cubic meter with 100 million dots, how many of those dots would be PM2.5? 0.4 is how many, less than 1 dot. The controls do have public trade-offs. Standards often say you can't, standards can't consider the cost, but that's the cost of compliance. That's the cost of telling a truck driver he can't drive his truck. That's not the cost of his family losing their income, or her family losing their income. So there are these trade-offs. Cost of food, cost of goods and services, availability of milk, things like that. The controls also affect air chemistry. We won't go into that. But particulate material are the sites for destruction of ozone chemistry. And therefore, if you change the particulate levels downward, you could increase the ozone levels and other gases and particles. So the air chemistry is not considered, along with the trade-offs. And these are health trade-offs. I'm not worried too much about how much it costs to tell someone they can't farm or whatever, but I am that trade-off. But I am worried about the health consequences of that. Some remarks. One of the bottom lines as a result of what I've been describing is when you perform a risk analysis, you should perform it on the decision about a substance, not the substance. Because you can isolate any substance. Sodium chloride causes heart attacks and high blood pressure, and you do a linear extrapolation to the safe level, and it's going to be 0. So should we ban salt from our diets? So looking at single pollutants leads to kind of absurd standards. You have to consider the consequences of a decision about that pollutant. And you also definitely have to consider all the consequences of a regulation instead of just the ones you're interested in. The next slide had references. I think I'll point out right around the middle, Martinson, because Jim Enstrom asked me to show a slide. It's from my ethics book on biomedical ethics. And this is called Science is Misbehaving Badly. NIH-supported scientists were contacted and asked, had they ever participated in any of these behaviors? Now, misbehavior is currently defined as fabrication, falsification, and plagiarism. I would add another, and I did in my ethics book, bias. And that's the most dangerous one. Well, falsification is dangerous too. But plagiarism, who cares? That doesn't really pollute the scientific literature. But bias does pollute it. And I'll point out a few of these, just actually falsifying. About 3% of scientists say, yes, I have falsified data. If you look down at the fourth one, withholding methodology or results, about 11% have said they have done that. This is probably a minimum level. Probably more have done that. If we look at the one about in the middle, changing the design, methodology, or results due to pressure from the funding source, that's almost 13% of scientists say they've done that. So it's a little frightening to think how the scientific literature is being contaminated. And this is largely due to pressures on scientists. I'm under question now as a tenured faculty member because I'm not bringing in enough money from federal sources. Now I'd like to introduce someone that I really admire. He's the best epidemiologist I know, and I know quite a few. With respect to his training, he's actually trained as an epidemiologist rather than an economist or an engineer. He also is the most rigorous that I've met in terms of reporting everything the way he sees it and doing that fearlessly. And for that, he's been maliciously attacked. And personally, I'd like to give Jim Enstrom a hand before he comes up. Jim?
Thank you, Bob. I really appreciate your kind words and the fact I'm able to share this presentation with you. Tremendously accomplished air toxicologist. I'm particularly proud to speak at the DDP meeting on the 50th anniversary of the Apollo 11 moon landing, which was a triumph of honest science and engineering during the Cold War that made all Americans proud. In 1969, I was finishing my rigorous Ph.D. in physics at Stanford, and I had the goal of using the scientific method to make a discovery that would benefit the world. I could not imagine that 50 years later, I would be giving a lecture on pseudoscientists who have totally corrupted science in the area of air pollution epidemiology. I will focus on the corruption associated with the major epidemiologic study used to claim that fine particulate matter causes premature deaths. And I will also suggest ways to restore the scientific integrity to air pollution science and regulations. If you look at the first slide, it basically reviews a couple of the points that Bob made. PM2.5 comes mainly from combustion. The EPA established the 1997 National Ambient Air Quality Standard for PM2.5 as 15 micrograms per cubic meter. It then lowered it to 12 in 2012. And it's based largely on one 1995 American Cancer Society secret science epidemiology claim that PM2.5 causes premature deaths in what is known as the Cancer Prevention Study 2 cohort. And this air quality standard has been used to justify many of the major EPA regulations that have multi-billion-dollar economic consequences in the United States, particularly in California. And I list a number of the different rules. My calculation of the inhalation of PM2.5 is consistent with Bob's. I calculate about the U.S. adult now inhales about 1 gram of PM2.5 in 80 years. And I won't go through the calculation in general, but it's based on average exposure, which right now in the United States is estimated at 8.4 micrograms per cubic meter. And this is a trivial amount over a lifetime. I'm going to do J-Layer one better. My monitor covers both PM2.5 and CO2, and right now it is reading the dramatically high number of 1.30 micrograms per cubic meter. That's far below the EPA standard. In fact, the daily standard is 35 micrograms per cubic meter. So we're all safe in this area. There's no known health effects at 1.3 micrograms per cubic meter. Okay, key reasons why PM2.5 doesn't cause premature deaths. First of all, there's no etiologic mechanism that shows through experiment or otherwise that inhaling 1 to 5 grams of PM2.5 causes death. Second, there is no strong association in epidemiologic studies. These associations violate all the standards, normally called the Hill standards, for establishing a causal relationship in epidemiology. There are tiny relative risks that have just been used by the activists to claim an effect because they're generally above 1.0. Third is ecological fallacy, where monitors are used to assign to millions, or in many cases less than that, but certainly to all the people that live in a certain city or county, one specific value that's associated with a monitor. But as I just showed here, if you actually look at monitors that are next to you, they don't necessarily show anything about a monitor that's located out by a freeway. Fourth is a reason that I was able to gain access because of my long association with the American Cancer Society, which started my career in epidemiology back in 1973, that reanalysis and transparency yield no effect in this seminal study, this 1995 study. I'll go into that a little more during the talk. Next is, if you actually look at the totality of the existing evidence in the United States, there is no effect. This is contrary to the claims that are in the EPA report of 2009 and the other activists. I'll also review that. So the focus of my talk is on the American Cancer Society Cancer Prevention Study 2. And this has been controversial ever since it was published in 1995. And the lead author is a agricultural economist named Cleve Arden Pope III. The American Cancer Society joined him, Michael John Toon, and others. And it's based on their analysis of data which they never released from this Cancer Prevention Study 2. This was reanalyzed by a Canadian group led by Krusky in 2000 by the Health Effects Institute. It never did the sensitivity analyses that were required to really do a proper reanalysis. In other words, all they did was show that if you do exactly what the authors did, you get their answer. But it doesn't show what happens if you try alternative methods of analysis. And they followed this up with a 2009 HEI report, which expanded on the data that was originally published in 1995. Again, they didn't address any of the criticism that had arisen by 2009, which included my publication in 2005. Very unprofessional. In March of 2017, I published a major reanalysis after I had gained access to the CPS2 data, a very old version of this data, but enough to make some reasonable reanalyses. And this showed that there was no effect if you used the best available PM2.5 data and you used all the information that was contained in this CPS2 cohort. I followed that up with another paper in May of 2018, which added more evidence and showed that they really knew a lot about this in the 2000 reanalysis, but they didn't actually analyze these alternative methods, and they didn't state that there were these kind of differences. This is just a quick summary of the findings in my 2007 paper. It's a little dense to go over right now, but the point is, if you use different types of data, in fact, one that's called the Inhalable Particulate Network set up by EPA, done by a scientist named Hinton, you come up with no effect. 1.02, where 1.00 is no effect. If you use data that's actually contained in the 2000 reanalysis report but not used, that's the second line down, you come up with the exact same answer, 1.02. But if you use the data that was used in the 95 paper and was the only data that was used in the reanalysis, that's called the HEI values, you come up with a positive effect, 1.08. And there's also additional analyses if you break down the effect by the Ohio Valley or the rest of the United States. Separately, you get no effect using any of the different PM2.5 data. So there are major problems in the claim that there's any effect in this cohort. So I want to go through the three principal people or organizations that I think are responsible for this, what I call a travesty of epidemiology. Cleve Arden Pope III is an agricultural economist, self-proclaimed as the world's leading expert on the effects of air pollution on health. He got a Ph.D. in agricultural economics from Iowa State University on the dynamics of crop yields in the United States. This certainly qualifies him as an expert in air pollution epidemiology. He recognized my 2005 paper in a review he did in 2006, but he hasn't cited me since. And we had a major teleconference in 2008. We had a major conference with 6 scientists on both sides of the issue that was in Sacramento in 2010. That resulted in no action by the people that disagree with us. Then there was defiance of the 2013 House Science Committee subpoena that was requesting this underlying CPS2 data. There was another paper published in 2013 which omitted many of the null results in California that, and obscured them. And then he's refused multiple invitations that I've made over the last 4 years to come to conferences and debate me or present evidence that I'm wrong. And he's refused to confirm or refute my 2017 findings. In fact, his response was, study by Enstrom does not contribute. Now, if that's not an unprofessional response, I don't know what is. So I basically just don't exist in his mind. He's not going to claim I'm wrong, he just complains, I just do not contribute. The other major responsible group is the American Cancer Society, all the way up to the top. The CEO, Reedy, the former, recently resigned Executive Vice President Brawley, the head of epidemiology currently named Susan Gapster, the prior head who was the author on the 1995 paper, Michael Toon, and their data analyst, Ryan Diver. They've refused to engage in any cooperation. They refused the House Science Committee subpoena. They've refused even to work with us, not even give up the data, but just conduct analyses that we propose. And they amazingly have on their website that this is their second proudest achievement, that their data is being used for EPA regulations. Of course, their first proudest is the association of cigarette smoking with lung cancer. Totally different category of strength in epidemiology. The third is this supposedly neutral group, the Health Effects Institute in Boston, President Daniel Greenbaum, and a chief scientist, Aaron Cohen. They selected for the Reanalysis a 31-member Canadian Reanalysis team, mainly statisticians and geographers, to reanalyze U.S. epidemiology. They didn't select U.S. epidemiologists, which would have been an obvious choice. And in their report in 2000, they didn't conduct the sensitivity analysis, which was part of their mandate. And they didn't use the best available PM2.5 data, which I went over in a previous slide. And since 2002, they've refused to provide me with essential data that showed. I was particularly curious about the fact that the cities in California had very low risk, but they never provided me with the data broken down by cities. And they have refused to address the findings in 2017 that I published. In fact, they allowed one of the key authors who's been involved with the reanalysis and in subsequent papers of CPS2, named Richard Burnett, a Canadian statistician. He made a presentation at the April 2018 HEI conference doing a meta-analysis that showed a very strong, in terms that are used in this area of epidemiology, of 1.1 for PM2.5 and total deaths. Well, that got me totally outraged because they didn't invite me to give my presentation on data. They just basically continued on now for over 2 years. Now, a lot of this has changed. The attitude of EPA has changed dramatically with the election of President Trump and the change in leadership of EPA. There's been a slower change in the career employees of EPA, but one of the main issues that's come up is a carryover from the House Science Committee. It's called the EPA's proposed rule, Strengthening Transparency in Regulatory Science. And I want to read you a couple of sentences from this proposed rule. This document proposes a regulation intended to strengthen the transparency of EPA regulatory science. The proposed regulation provides that when EPA develops regulations, including regulations for which the public is likely to bear the cost of compliance, with regard to the scientific studies that are pivotal to the action being taken, EPA should ensure that the data underlying those publicly available are publicly available in a manner sufficient for independent validation. That seems completely relevant, completely reasonable, consistent with the scientific method. And it's been attacked viciously. This presentation, following the introduction of that a month later, in May of 2018, there was an EPA Science Advisory Board meeting. Professor Phalen is on that EPA Science Advisory Board. I submitted comments supporting the importance of this rule based on my access to data that shows that there are important differences, that the findings are different depending on, at least in this case, who analyzed the data and what the actual PM2.5 measurements are used, so forth. I also submitted additional comments in August of 2018, supporting the transparency rule. The Harvard is so upset about this. They wrote a letter in August of 2018, 34 pages, written by a lawyer of the law school named Wendy Jacobs, co-signed by 96 professors, urging withdrawal of the proposed EPA rule, making claims such as the proposed rule does not serve its stated purpose to ensure that regulatory decisions are based on valid science. The rule will jeopardize the health and safety of infants, children, and adults in the United States and beyond. This was signed by the highest officials at the Harvard, the president, the dean of the Harvard T.H. Chan School of Public Health, the dean of the medical school. There's 4 professors involved with seminal research on the claims of PM2.5 deaths. Layden, Dockery, Domenici, Schwartz. And most troubling of all is the name Eric Rubin. Eric Rubin will become the new editor of the New England Journal of Medicine in September, and he does not believe in transparency. This is shocking. I mean, I've never been able to get anything other than letters in the New England Journal, and it's not going to get any better under Rubin. I had a group of UCLA graduates and graduate students who had formed a sort of consulting enterprise called Intrepid Insight, do a statistical review of competing findings in fine particulate matter and total mortality. I basically gave them Burnett's presentation that he made at the HEI conference in April of 2018, and made sure they had all access to all the underlying data. They did a tremendous job and this is, we're talking people that don't have any more than a master's or bachelor's degree, and they made a statement about data transparency, and this is all on their own. I have no authority over them. I know a couple of them, but I don't have any authority over them. All 9 of these directors and contributors voted to support data transparency as a principle, and because the Pope 95 paper is used to support public policies, there's an even greater justification for releasing the underlying data in that study, the CPS2 data. They conducted meta-analysis of 8 U.S. cohorts and 6 California cohorts. I summarize these quickly here. They're a variety done by different authors, but several of them are done at the Harvard School of Public Health, which has been an activist on this and published the first paper in '93, the famous Dockery paper, Dockery and Pope. They come up with findings of the ratio. These are just the published numbers that are in these papers. And it comes up with a ratio. If you used fixed effects, it's 1.02, and if you use random effects, which applies here because the results are scattered, you come up with 1.01, not significant. So even published data, aside from all the limitations that exist, show no effect nationwide for 8 cohorts. There's another controversial cohort that came out of the Harvard study that I have not included here because there's conflicting results from that study. Then the 6 cohorts in California, including the one I published in 2005, show that it comes out exactly at 1.00 or 0.999. And because the results are so similar, the fixed effects and random effects yield the same result. What I've done now, quickly to go through these, the professors in California have, in my view, been the main source of the problem. And I've put together a sequence of emails and telephone calls to a number of faculty members at USC, and they've all been non-responsive. And they are part of the effort. One of these professors organized Burnett's analysis at HEI, didn't invite me, even though I have known this person for many years. So we are zeroing in on what I think is the source of the problem. That is professors who would rather engage in activism than honest science. This is important because they were proposing, the regulatory agencies are proposing a sales tax. It's called the SB 732 sales tax that would apply to everybody in Southern California for more regulations that aren't scientifically justified. This was written up by an investigative journalist in April this year, Katy Grimes, on her publication called California Globe, and it's called A Totally Different USC Scandal. There have been a number of scandals now at USC for the last few years, most of them emanating from the medical school, and this is very troubling. This group of investigators has received, based on the information about their funding, something on the order of $500 million during the last 25 years. My claim is they've misused this to exaggerate the health effects in air pollution in Southern California that's then been used by the regulatory agencies to impose scientifically unjustified regulations. And I've gone up to the top at USC, and they're not willing to do anything. They don't think anything inappropriate's been done. So this is just going to have to be decided by the general public. One of the publications that is used every year to promote the dangers of air pollution is called the American Lung Association State of the Air. And in 2019, they made the claim that 43% of Americans live in unhealthy counties, and that you can prevent, like they make a number, 34,000 premature deaths if you can lower the PM2.5 level by 1 microgram per cubic meter. And they've got all the worst counties in California, 8 of the 10 most polluted PM2.5 counties in California, all 10 of the most ozone polluted are in California. And what I did is I looked at the citations in this publication, comparing the 2010 version, 2019. You look at the same names of these investigators. The main people that promote the health effects are the ones that are cited. And you see it's grown from 2010, 69 citation to 138. And for the USC professors, it's grown even more from 26 to 81. And so the citations are all by the activists. If you look at the citations of critics, like myself and Professor Phalen, we're still at 0. 0 citations. So this publication has no credibility, in my view, and yet it's given, it's distributed all the newspapers and so forth every year. But that's how biased the situation is. This is an editorial that came out in April 25th, and they're weighing in, and they're upset that folks like us and that EPA, the new EPA, are questioning this. The title of this editorial is "Stop Denying the Risks of Air Pollution." Research linking fine particulate pollution and premature deaths is under attack in the United States and other countries. And they're upset at this, but then they don't give authors like myself a chance to publish why. And so we have a very accomplished and fair-minded new head of the EPA Clean Air Science Advisory Committee. His name is Louis Anthony Cox, Jr. He submitted a Nature letter that responds to their editorial, and he makes a number of important points. Sound science entails use of clear definitions, explicit derivations of conclusions, reproducible tests of predictions versus observations, and careful qualification of causal interpretations and conclusions to acknowledge remaining ambiguities, and so forth. He also wrote another paper about communicating deaths more clearly. That came out in April of this year. Tremendous guy that is going to work on straightening out the way EPA interprets evidence. I filed a complaint in June with what is called the EPA Science Integrity Official against their lead integrated science assessment staff person named Jason Sachs. I don't like to do this, but this man has been at odds with me for a decade. He was involved in the 2009 Integrated Science Assessment, which is the last one that's actually been finalized, and he made just an outrageous claim. Collectively, this body of evidence is sufficient to conclude that a causal relationship exists between long-term PM2.5 exposure and total mortality. This is after a decade of evidence, which I summarized above in the meta-analysis, showing no effect. There's absolutely no effect. It's not a question of a small effect being possibly causal. There's no effect. So we'll see if we get any response back on that. So my conclusions are strong evidence from 8 major cohorts that there's no causal relationship, strong evidence that the lead researchers involved, EPA and HEI, have made false statements about PM2.5 deaths. The EPA must adopt this rule strengthening transparency and regulatory science. There will probably be some movement on this in the coming months, from my understanding, that it probably will be adopted over the objection of all the activists. The rule must be used to finalize these assessments, the ongoing assessment of PM2.5 and the next reassessment of ozone. And there must be, in my view, an aggressive campaign against all the pseudoscientists that continue to promote these claims, even though the evidence continues to get weaker. I'd like to conclude with a couple of worldwide points. There was a paper published in Lancet called Global Burden of Disease by HEI author Cohen and Pope were 2 of the main authors. Even using their flawed methodology, they come up with only 88,000 deaths in the United States out of 4.2 million worldwide. So that's 2%. And so even they concede that most of the problem is in China, India, and Africa, which is reinforced by this satellite map. This is done by the World Health Organization. I didn't have anything to do to preparing this map. And you can see that the red is in Africa, India, and China, and the United States is basically blank. So this is an important thing. In other words, why are American scientists focusing on grinding down on regulations in the United States when this is a worldwide problem in other countries? And my last slide, in many ways, is the most important. And people must realize this guy. He is very smart. He's been the president of the People's Republic of China for 6 years. He's 66 years old. And recently, they declared him president for life. And his, I think, role model is Mao Zedong. And he doesn't care about air pollution. He just assigns his citizens gas masks and say, let's take as many of those American jobs as we can, and then we'll manufacture them with gas masks, and we'll send the products back to the United States and let them put all their citizens out of work. So this is where you have to put some balance and perspective on this issue, and hopefully, ideally, I'd like to get some support from people in this room. There are already a number of people that are helping, but the more support we can get, the faster we can change this around. And I think it really is changeable, given the current administration and the evidence that shows this is not a problem any longer in the United States. Thank you very much.
Well, of course, I want to thank you. Because of Jim Enstrom, I got involved, and I guess my call is to everyone here. I am a member of the Citizens Advisory Committee of the San Joaquin Valley Air Pollution Control District. People in this room, I think, would have the opportunity to volunteer and contribute and insist on good science. It's very hard to do because these are very entrenched bureaucracies. I mean, they're spending billions of dollars just in the San Joaquin Valley area. And when there's evidence such as Professor Enstrom and Bob Phalen bring out, it jeopardizes their jobs. But I think the approach that we take, which is fairly ecumenical because I have environmentalists who are joining me, calling for an update of the science within the valley. We've spent $60 million of our money on studies. None of them are health-related studies. So I say thank you, and I'd encourage others to get involved.
Amazing presentation, Jim. We're very proud of you. You have true grit.
Thank you very much.
I appreciate both of your presentations very much and find it really, really shocking that the scientists and universities have, and these publications have turned their back on wanting to be more transparent. And actually, this sounds so much like the whole climate science issue, too, that there are those scientists who say it's settled and yet the data shows otherwise. But at any rate, I wonder if you're placing too much hope on the EPA when it sounds to me that the many universities are entrenched with professors and presidents of those universities who are simply not wanting to have science be transparent. What about the granting organizations? It seems to me if you can speak to them, the National Science Foundation or whoever gives grants to these universities, that would be a source of shutting, for opening up transparency, I would think.
Transparency is a good case for EPA. Has it really changed? Because they received almost 500,000 comments against transparency. So it'll tell you how strong our president is and the EPA administrator is.